Hello, this is section 4.5, which is on exponential and logarithmic equations. So we've talked about in the previous section so far what an exponential and what a logarithmic function are. Now we're going to deal with equations. The first type that you're going to see is you're going to see 5x equals 125, which is very similar to what we had 2 sections ago, where what I would suggest that you do is see if there's any way, is there any way you can make 125 into 5 to the somethings. If there is, it'll make you go a little bit quicker, a little bit faster. Since there is, 5 to the third is 125. If the bases are the same, then the exponent should be the same. Okay, those are the easy ones. Whenever the bases are the same, set the exponents equal to each other and go from there. Now, the biggest things is what happens if they're not? Okay, is there a way I can make a 7 into 3 to the somethings or vice versa? No, there's not. Okay, so for us, what we're going to have to do is we're going to have to figure out how do I find x? Well, when the bases are not the same, what you do is you end up logging both sides. Now, once you do something to one side, you can do it to the other. And notice that it's base 10. We didn't have to do anything with the bases there. We just put a log into both sides like that. It just automatically becomes base 10. The reason why we do that is because then we can use those laws that we had on one of the previous sections to then take the exponent and move it to the front. So it becomes x plus 2 times the log of 3 equals the log of 7. Now the reason why I put it in parentheses is because that whole thing was the exponent, not just the 2 and not just the x. It was x plus 2 was the entire exponent. So that's why it began or was in parentheses. Now what I'm going to suggest that you not do not distribute this out. It's going to make more work for you, and I don't think you want to do that if at all possible. So first thing that I would do is, it says multiplication, so in order to get rid of multiply, we divide both sides. When I do that, that cancels that out, leaving you x plus 2 equals log 7 divided by log 3. And then I want to get rid of adding, we subtract. So I end up with x equals the log of 7 divided by the log of 3 minus 2. That's the exact answer, because when you type this into a calculator, it's not going to come out to be exact. It's going to be this long decimal that continues to go on forever. That is the exact solution. When you type that into a calculator, first thing you would type is you type log, automatic parenthesis 7, close it, divided by log, automatic parenthesis 3, close it, minus 2. And you end up with negative 0.229 if you go to 3 decimal places. Okay, so again, this is the exact solution. This would be a calculator version solution, because those do go on forever. They're irrational numbers, so therefore writing a decimal equivalent usually depends on how far you want to write your decimal. Our book, for instance, will say round your answer to 3 or 6 decimal places or 4 decimal places or something to that effect. So that's typically how those go. But again, if the bases are different and they cannot be rewritten as each other, log both sides, take that exponential out, and then just keep going and solving for x. The other type is, remember when you had e as a base, the ultimate goal is you're trying to solve for x. Okay, and when you solve an equation, you're basically undoing the order of operations. The order of operations states grouping symbols, exponents, multiply, divide, add, subtract. Well, when you're solving an equation, you're working in the opposite direction. So you're trying to get rid of adding, subtracting first, then multiplying, dividing second, then exponents, then grouping symbols. So for this particular problem, it says 8 times this. So the first thing I'm going to do is I'm going to divide. e to the 2x equals 20 over 8. You can leave it as 20 over 8. It's not going to hurt you if you don't reduce the fraction, because we're going to end up doing something to it anyway. So the fraction itself, if you leave it as 20 over 8, it's not going to hurt you. Now, because our base number is e, we're going to ln it. If the base number was an actual number, like a 4 or 3 like we had in the last problem, then we log both sides. Recall from the E section, which was section 2, when we have E and ln next to each other, they cancel each other out, leaving you 2x equals the ln of 20/8. Okay, so, ew, it's a bad looking 20 there. Then we divide by 2, and we get x equals the ln of 20/8, and divided by the whole thing by 2. That's the exact answer. When you type this in the calculator, the ln should come up with an automatic parenthesis. You type 20 divided by 8, then close it, then divide it by 2, and you'll get the answer of approximately 0.458. Okay, so just when you see that, depending on if it says to find the exact solution or approximate solution, again, that's typically however the answer is going to look. It's either going to look like this one for exact or this one for approximate. I'll give you another one. E to the 3 minus 2x equals 4. So first things first, is there any adding and subtracting outside the exponent? No. Is there any multiplying or dividing on the outside of the exponent? No. So how do I get rid of e? Is I ln both sides. When I do that, they cancel out, leaving me 3 minus 2x equals the ln of 4. Now I subtract 3. A lot of people mess up that part. They say that it's adding 3, but it's the sign in front of it rather than behind it. So be careful with that. Ln of 4 minus 3. Another big time mess up is right here. The ln of 4 minus 3 is not the ln of 1. Okay? It's not the ln of 1 there. The ln of 4 minus 3 is not the ln of 1. It's the ln of 4, a number, minus 3. Okay? And then we divide everything by negative 2. So, when you're typing this in the calculator, and by the way, this right here would be the exact solution. When you're typing this into the calculator, this is where you got to be extremely careful. What I do, because there's 2 parts on the top, I would put parentheses, ln of 4, close it, minus 3, divided by a negative sign 2. The reason for that is if you don't put that in parentheses, it's going to divide this by this first, and then just simply add or subtract it to the ln of 4, which is not what you want. So when it's got multiple tops, I would always put it in parentheses just to make sure you're getting the correct answer. And the exact solution was already circled. The approximate solution would be 0.807. So that's kind of how, again, how to solve them. Another way that you could solve them is, and I'm just writing the same problem down, is something that we learned way back in chapter 1, section 9, and it's on solving them graphically. When you have something equaling another something, you could put this into y1 and this into y2 and use the intersection feature on your calculator. Intersection, again, is you hit second and the trace button, and it's down to option number 5. Okay, and what it'll ask you to do is, if you're on the first curve, second curve, answer, and it's only going to be the x coordinate. It's not going to be the y coordinate. The reason why it's only going to be the x is because you're only finding x. You're not finding the y. There is no y in the initial problem. If you did it that way with the calculator, or you using the graphical way of method, you would get the exact same number that we just got by typing it into our calculator. So, just so that you are aware of it, they are the exact same methods or same ways. Okay. Another type of equation that would happen is if you have it simply put like this, and again you're trying to find x. This particular problem you've done in a college algebra setting numerous times. You just probably don't recognize it right away. This is, again, a quadratic type of equation. The reason for it is because you have e to the x and e to the 2x there. That's quadratic type. Okay, so what you're going to do is you're going to treat this like a quadratic equation. Now, putting it in the quadratic formula, probably not the easiest thing to do, but factoring it is. So what times what gives me e to the 2x is e to the x and e to the x. Now the reason why that is, remember when you're multiplying things with same bases, you add the exponents. 1x plus 1x would equal 2x. So that's why that works. Then what times what gives me negative 6, but adds it to be negative 1, would be negative 3 and plus 2. Alright, so then from here, what I'd like to do is I'd like to put each of those equal to 0 and solve for x. So if I add 3 over, I got e to the x equals 3. In order to get rid of e, you ln it. So I got x equals the ln of 3. And whatever that is in my calculator, the ln of 3 is going to give me a number like 1.099. Okay. If I do the other side, however, I get e to the x equals negative 2, and when I try to ln that, it's going to come up as x equals the ln of negative 2, but if I actually put that in the calculator, it's not going to work. The reason for that is because when you looked at all those ones before when we were talking about it, any of these things, like this, should be greater than 0. Okay, so any of the numbers like that, it's not possible. Okay, it's got to be greater than 0. So anytime you get a negative there, you got to throw that one away. So this one actually gets all thrown away, and this is my only answer I have for that problem. Anytime you have that where it's a negative, it's not going to work. Where it gives you a negative ln, negative log, negative e, because you remember the domains were from 0 to infinity. It was not negative. Okay, so that's kind of one of those things where the negatives will not exist for you. The next type that you might see is if you have something like this that has a ton of logs going on involved. Okay. Now, first of all, there's a lot of logs going in here. I don't know where to start. So, in order to actually get this a little bit simpler for us, I'm going to combine these two logs here. And remember, going back to the laws, adding is the same as multiplying. Now, I could FOIL that out, but I'm going to talk about that here in just a second anyway. So, once I get it to this stage, using those laws, remember adding is the same as multiplying. Now from here, the one thing that I hope that you guys realize or understand is this equal sign right here is important. The equal sign is pretty powerful. The equal sign is one of those things where if it's an equal sign, it should be this matching the same on both sides. You can't have, two things that aren't quite the same, they have to be identical. Kind of like twins, like identical twins versus fraternal twins. Fraternal twins are not the same because usually one's female, one's male, whereas identical twins, they look identical. It's hard to tell them apart. That's like an identical twin situation, which means this part should equal this part. So what I do is I drop the logs off. And now if you want to FOIL from here, we get x squared plus x minus 6. And now the logs are gone. And we try to solve for x. So the first thing is, let's get rid of the x squareds. I get 1 equals x minus 6. Add 6 to both sides. And x equals 7. Now, when you get an answer like that, plug it back in and see if it gives you a negative underneath any of those in those log spaces. If it does, you have to throw it away. Okay? So for instance, if I put 7 here, 7 here, and 7 here, if I get a negative anywhere when I do that, you got to throw it away. If it's the only solution that you got, then you have no solution. So be very careful with that. So in this case, we're good. Everything worked out fine. So x equals 7 is a good answer. If it didn't, then you gotta stop and put no solution. So maybe another one here. Okay. Again, in solving equations, no matter if I'm solving with logs or not, first thing you get rid of should be adding and subtracting. So the first thing I'm going to get rid of is I'm going to subtract 4. A lot of people mess this up right here. They take 4 plus 3 and they make it 7. That's not how you solve that. Okay, it's got to be where you get rid of it by adding or subtracting first. So you have 3 log 2x equals 12. Then you get rid of the times. So the log of 2x equals 4. Then rewrite this as an exponential. Anytime you have a log like that, rewrite it as an exponential. That should give us the right answer. The base number when it's not written, again, is 10. So 10 to the exponent of 4 equals 2x. 10 to the 4th is 10,000. Divide by 2, and I get 5,000 as my answer. Okay. Again, if I were to plug 5,000 in back in for x, if that gives me a negative there, got to throw it away. If it's the only answer that we have, then we have no solution. And again, I could have made that, or I could have used the, I could have graphed it. I could have put this as y1 and this as y2 and see where they crossed. Now, getting an answer of 5,000, which means I got to go adjust my window quite a bit in order to find that. So, just so that you are aware of it, that's one of the possibility for you to actually solving them is to using your graphing calculator to find them. But anyway, that's it for section 5.